This page may look familiar. In this video, we're going back to some old notes and finding out how you can tell if a relation is a function from a graph. We already found in this first example that this relation is a function. Just a reminder, a function has only one output or exactly one output for every input, or each x can be matched up with only one y. So we're going to go ahead and see how we can tell on our graph and see if there's an easy way to just look at a graph and you can go, yep, that's a function, or no, that's not a function. I'm going to go ahead and rather than try and look at this map, I know how to graph ordered pairs. So I'm going to graph the ordered pairs that this map came from. These two things represent the same thing, just so you know, like you can tell -5, 2 is right there. I'm going to graph the ordered pairs on my graph over here. Remember that your x-axis goes horizontal, these actually have labels, and the y-axis goes vertical. So we're going to go -5, and I actually have it on my graph, up 2 for my first point. -1 goes left 1, and then up 4 for my second point. 0, 1, 2, 1, and 4, 4. Okay, so kind of weird. This just looks like a random collection of dots, but we want to look at anywhere that we look at an x, there is just one y value. So let's tell from a non-function and see if we can tell a little better if we can just look at a graph and see. I'm going to go to this one. This one's not a function, so let's see why it is by looking at our graph. I'm going to plot -4, 2, -1, 2, 0, 2, 2, 2, 4, 2, and 4, 5. So in our previous video, we talked about really like this could be a function. That's fine. It's fine to have them all in that line right there. The really important part is that our one input of 4 had an output of 2 and an output of 5. It had 2 outputs. And you can see that looking right here. Our input of 4 had 2 outputs. So when you go to read your graph, and normally when you're reading your graph, you read the x first and then you look up for the y. If you read the x and you can't decide between two things what it should be, that's not a function. In our notes, we describe this as points being stacked on top of each other, or you could even just like draw a line. If you can draw a line straight up and down, a vertical line, and it has 2 of the points from the relation on it, it's not a function. Let's go ahead and summarize that. It's called the vertical line test. We could even write this as VLT, not like a BLT, but a VLT? I don't know. Any vertical line will intersect the graph of a function only once. If there is one point, just like on this guy, where the vertical line intersects 2 points, then it's not a function. Now let's look at these graphs. These graphs look a little different. They're not just like a bunch of points, they're lines graphed, and you have had experience graphing this type of line. These are also things that you'll graph in the future. And what we want to be able to tell is it a function? So we're going to see if the vertical line crosses once or more than once at any given point. Now let's just do some practice. When you look at this, your input on this one is 1 and your output is 2. So that's how you tell what your input and output are here. And you could find that because these are all connected, you could find those points anywhere on that graphed curve or anywhere on that line. So there's infinitely many x's and y's. That's why it's easier to just look at this graph rather than to look at a table sometimes. Okay, we look at this graph and we're going to draw a vertical line. And here, this one looks like it crosses more than once, but like, see how this line is curvy? If I could draw a perfectly thin vertical line, it would just touch that one point right there. And then this guy, only one. This guy, only one. This guy, only one. This guy, only one. So this one is a function. Okay, let's look at the next one. Okay, here, there's only one here, so that's great. Does that make it a function though? If at any point an input or an x has two outputs, then it's not a function. Okay, let's look at this guy. And I'm going to just try and draw lines where I already drew points. And it looks like there's just one point on the graphed line for every vertical line I can draw. So this is a function. Now, is every line a function? That might be something for you to think about. If every line has it so that an input has exactly one output.